Thank you for joining us here. We're really excited to chat with all of you, get to know you. Jonathan and I will be sticking around after this, so if people want to go deeper, is anything that we're talking about right now, very, very happy to do so. But first and foremost, who are we? So I'm Amy Reams. I'm here from Anomalo. I'm flying in from Seattle, Washington. I'm Anomalo's Vice President of Business Development and Marketing. So I oversee our partnership and go-to-market efforts, partnership with folks like DBT, which we're very excited to be part of their partner network and portfolio here. Jonathan, you want to introduce yourself?
Sure thing. Oh, I'm Mike too, great. I'm Jonathan Karon, came out here from Portland, Oregon, work for Anomalo as well. And I have this funny title of Partner Innovation Lead, which basically means my job is to figure out how we help all of you by being in the right places and all of the different tools that you use so that it's super easy to plug in data quality, respond to data issues, and just generally everyone who touches data knows what's going on with the quality at all times.
Yeah, Jonathan's got the coolest job ever, right?
Much.
Kind of product, kind of partnerships, gets to blend both. But why are we here, right? We're here because we want to tell you about a couple comments we've been hearing recently. I want to see if any of these comments resonate with you all. Right, we hear the comments, we cannot tell when data is arriving late or incomplete. True story, we're also hearing many of people say these days our leaders or customers find key issues before we do. Or we spend too much time developing and maintaining rules. Right? The list goes on and on. I won't read every quote to you. True story, I did not hear this in the coffee line. Where I heard this is in our gong calls, our calls with prospects, our calls with customers. Right? And there's a key theme that you're seeing in all this. And that theme is data quality. Right? And what do we mean when we say data quality? Right? It's a term that's been around for a really long time. People like to throw it out in many ways, shapes, or forms. So let's talk about it, right? Let's talk about what we mean when we say data quality. So if we can all get on the same page here, we can all level set about what we're talking about. I used to work at Amazon, so I like to think in my logistics and shipping methodology here, thinking about boxes. Right? So let's just say your data is a box. Right? Here's this box. You see it, you have your data. There's two ways to think about this box as it pertains to data quality. The first is something that's called data observability. Right? This is a term, I'm sure you've all heard this before. Right? It's a term that essentially is asking, did this box arrive on time? Was this box the shape and size that I expected it to be? Great, if so, move it along, right? That's my box, I've seen it come through my factory, my warehouse, I'm gonna keep it moving. But what happens when you open up that box? Right, opening up that box and looking at the contents of the data in that box, that's what we call data quality monitoring. Right, trying to understand if there's any drift or changes within what you expect to be within your data relative to what is in your data. So why does this matter, right? Why am I defining these two terms? Well, it certainly matters when we think about the different business impact relative to different folks in the space. So show of hands, who here is more on the data engineering side of the house? All right, I see Tony raised their hand, some other folks. What about on the business side of the house? Any business analysts, data scientists? Yes, perfect, thank you. This is gonna be drastically different for the different personas that just raised their hands. Let me break this down. Right, this is an overly simplified version of your data stack. Right, I'm sure you all could draw your own picture. I would welcome seeing that if you all want to take those notebooks and draw it, but a simplified version of the data stack. Right, and we're talking about some of these issues, whether they're observability issues or quality issues, they're going to happen throughout this entire journey. Right, when you're talking about your different event data, data feeds, SaaS application data, you're going to have missing feeds, you're going to have duplicate data, you're going to have late data. We love, love, love our friends at DBT, but there's still issues there in the transformation level. Right? You might have job failures. You might have SQL bugs. So what does this mean? Right? By the time the data gets into your data warehouse, it's often delayed, incomplete, invalid, or anomalous. Right? Those are both observability and quality challenges, if you think about the box analogy just a second ago. So for the analysts and data science folks that raised their hand, I'm sure the top of this is screaming at you all too loudly. Right? What do you have? You have broken dashboards. You have misleading metrics. If you're using data within your product to change the customer experience, you now have data that's fed into unstable models, or you have erratic predictions. Right? This is really, really challenging, right? And for the engineers that raised their hands first, I'm sure you're used to getting the calls from the business folks saying, what the hell, data on fire, this is wrong, this is broken, fix this, right? But you were thinking about data in an observability sense on the engineering front. And your counterparts on the business side were thinking about opening the box and thinking about the contents of that box, right? And that's a big issue, right? We need to think about both. We need to address both challenges to make sure that across this entire stack and journey, you can trust the data feeding every single touch point here. So good news, bad news. Good news is we'll talk about a solution for this. Bad news is that GenAI is making this problem worse, right? Because what I've just talked about so far is largely in the context of your structured data, right? The data that you have in a Databricks or a Snowflake they've been using for those purposes that we just talked about a second ago. Remember my friend the boxes over here? With GenAI, what we're now talking about is leveraging unstructured data as well, right? So the data now is coming in many different shapes, sizes, forms, right? They're call transcripts, they're PDFs, they're files that you have, right? And I'm sure you all on the enterprise front here can understand that when you look at your data, 98% of it is actually unstructured, right? So great opportunity to use that data, but the reality is you now have to take that data and bring that data to the model, right? That's kind of the biggest paradox that we're seeing now with LLMs and GenAI, is that no model is just going to work off the shelf unless you have the right data to feed that model, right? And so you all need to know, similar to what I was just talking about a second ago, that that data is of high quality, right? You need to understand that you can trust it despite the volume of it, despite the many different shapes, colors, sizes, forms that these boxes are coming in, right? Because that little diagram I just talked about, now we have a whole new top of funnel layer here, right? We're going to have governance violations. We're going to have factual inaccuracies in our generative AI models, in our LLMs, because maybe that data is sensitive. Maybe it's off topic. Maybe it's outdated, right? So the data quality problems are just continuing to grow when you think about the implications of generative AI. Now I'm going to hand it off to my friend Jonathan, though, to help you talk about where you can start, right? Knowing this problem is pervasive, where do you start to simplify the solution?
Thanks, Amy. Yeah. So I am actually really happy about the kind of themes I've heard at Coalesce this week, because in a past life, I ran DevOps teams at a company that built tools for DevOps engineers. And so we did all of this work to create teams, right? Create cross-functional teams that could build and operate software at scale. And one of the things I learned from that was, yes, the business stakeholders just want everything to work, but when it doesn't, the worst thing in the world is surprises, right? And so we spent a lot of time figuring out, how do we create transparency? How do we have a status page so someone can go and say, is it my laptop or is the app broken, right? And everything I've heard about sort of DBT's product roadmap, about the way they're approaching mesh, about the way they're approaching tools for analysts, sorry, it's early, says to me that we're like making those same strides in the data world, right? We're going from DevOps to data ops. And so this is just super exciting because I spent 10 years building those muscles with teams. And so now, one thing that we didn't do was AI ops. And this was this idea that, gosh, we can just point machine learning at all of our ops telemetry for all of our software, and it'll tell us when things break, and it'll tell us where the root cause is, and it'll tell us how to fix it. And as of last year, when I kind of stopped paying attention to that, it was just a pipe dream, right? No one had figured out how to look at the exhaust from running software and predict failures. So when I met Anomalo, I was super excited because they've actually spent the time to figure out how to see those problems in data and how to approach, automatically detecting data quality problems, how to diagnose it, and how to kind of start down that path of root cause analysis. So that's long-winded, and it is early for me, so if I start rambling, just wave your hands and say, move on. Yeah, thanks, Amy. Whoops. So how do you start with, you finally convinced people that data quality is important, right? And the first thing a lot of teams I've talked to do is they start writing data quality rules, right? Whether these are expectations or unit tests or data tests, right? You go and you say, okay, What's our most important data? What tables does it live in? What are the failures in that data that are causing the most problems for the business? Let's build a big spreadsheet. And then let's write rules. And let's do all of this stuff. And that's a great way to kind of start understanding how do we approach data quality? How do we approach knowing when our data isn't what we expect it to be before our end users do? Right? But the problem with that is that as you scale, as you continue to build more and more data products and manage more and more data pipelines, the list of rules just gets longer and longer and longer. And at some point, things change, and you have to go back, and you have to rewrite some of those rules. You have to edit them, right? And getting into that pattern of writing data tests as you create models in dbt is great. It's a great habit to be in. But it still builds up this huge catalog of what on the software world we would call tech debt, right? You've got all of these rules that exist that have to be managed and maintained. And so you find yourself carving out budget to hire data engineers to just maintain a bunch of rules. And that hits a ceiling. With the customers we work with, there's a point at which it just stops working because they can't afford to hire another engineer for every new data product they bring in. So this is where we're lucky that, were there any folks who do data science or are data scientists in the room? There's one, okay, great. So this is where I'm kind of excited because for a long time the data scientists have been coming to the data teams and saying the data's wrong, could you fix that, right? Now, from the data science world, we get to give back a little bit. We get to come and say we're building tools for data teams, for data engineers, for analytics engineers. And that's where Anomalo started. Our founders ran analytics and growth at Instacart, and they said, this is an utter mess. We can't build another company like this. And so they sat down, and thankfully, Jeremy Stanley, our CTO, spent a long time thinking about how do I apply ML to the problem of data quality? And how do we build a solution where I just say, this is a table that I care about, and we let the software figure out what normal is, and we let the software continuously monitor that data and tell us when things go sideways. And so that's what we've built at Anomalo. And I don't just want to do a product demo. I want to kind of talk about our thinking behind that and what actually makes that work. Because it's one thing to say we have some great ML models that we just throw at the data. But it takes a long, careful, thoughtful process of figuring out how to apply those models in a way that actually solves the problem. So stepping back a little, this is what we would call the data quality maturity curve, right? Most companies go through this journey where they start with nothing, they realize they have a problem, they start to write rules, as I said, and then they find themselves managing rules, and it becomes really reactive. They're trying to get ahead, but there's just so much work to do and so many rules to manage. And they get really good at managing rules, but that's about where they get stuck at that third step. And this is where the ML approach comes in, and you say, well, let's step back. Let's figure out how to delete most of those rules so that you don't spend all of your time managing stuff that a computer can figure out for you, right? And once you break out of that cycle, and now you have some machine learning-based automation, now you can refine your process. You can kind of tease out the differences. We were talking earlier about the difference between statistically, I want to make sure that 99% of my data is right, and small variations aren't a big deal, versus every transaction has to be accurate in this table, right? And those are two different types of data quality problems that you need different tools for. So this is what I was talking about. We call it the doom loop, right? This idea that you get stuck editing rules, writing rules, planning for a couple of days worth of rule creation work every time you bring in a new data set or spin up a new pipeline. And it's just not scalable. And this is, I'm repeating myself now, but this is where ML can help you get out of that. So how does that work? We've worked with a bunch of great companies, some really big companies, and what they have found is that this actually does work, that once they have figured out how to apply ML to the data quality problem, their teams are more productive, they're able to do a lot of this work automatically. And back to the point of working with your stakeholders and your data users, they've allowed those analysts to come in and say, these 2 tables or these 5 columns or this query is really important to me. And I want to know if there's anything wrong with it. And they're actually able to deliver self-serve data quality to those users, where they can come in, they don't have to write SQL, they can say, I want to make sure this column is never null, I want to make sure these 2 columns add up to this 3rd column, alert me if it doesn't, right? And then we dispatch alerts to those users, they can come back in, maybe they can't diagnose or fix the problem, but at least they have a receipt, right? And they can come to the data team and say, hey, this is what's wrong, right? It's, this rule is failing on this table, it started on this date, and here's a bunch of data about that. And that, it just improves that interaction. It speeds up the process of figuring out what's going on. There's a lot less back and forth, especially in, distributed world. That can eat a day just getting on the same page with someone about what they're seeing. So there's a ton of advantages to this. So how do we do it? There's basically 4 kind of core insights or little experiments that we've had to work through to figure out how to make this work. One is time series predictions, right? ML models are great at predicting time series data, but every table's different, right? And every business is different. What's normal on Tuesday for you is not normal on Saturday in most cases, or on Thanksgiving Day, or on the Super Bowl. So we've had to tease apart time series prediction into a series of predictions that account for different kinds of patterns. So, different models look at weekly patterns, monthly patterns, yearly patterns, holidays, right, special events. And when you pull all those together, you can actually create a pretty good prediction for what the data should look like day over day over day. And this is a great thing. You can apply this to key metrics, like from your semantic layer, and you can actually have predictions about where those metrics are going. And if they fall outside of that prediction, then you can alert. And that way you don't have to set specific hard thresholds on those metrics to alert on, because those are super noisy. Second thing, we call this unsupervised machine learning. Technically, it's self-supervised for the data folks. But the idea is that instead of creating a bunch of rules, what we're doing is we're actually training a model on what a table has looked like historically, day over day, week over week. And then instead of having a huge list of rules that get evaluated, we actually use that ML model every day to look at the table again and say, has the normal day-to-day jitter in these fields changed significantly, right? And it doesn't catch every single row level change. Like if you have one null, probably won't catch that. But it's going to catch those big statistical changes in your data, right? So if you have suddenly a lookup table, is missing or corrupted, or a join doesn't work right, it's not going to be one record in your table that's wrong. It's going to be, hundreds or thousands or millions of rows, right? And so this is really effective at catching those like 1% or more kind of changes that cause a lot of trouble, especially up in your sort of earlier stages of your data tables before you've refined everything. Because if you're processing, if you spend a whole bunch of compute turning those very, very raw data sets into final products, and the raw data was off by a significant percentage, there was a lot of corruption in it, all that work has to be redone after you fix it. So we can help with that, catching big problems early. Who here actually gets paged or notified when there are data quality problems in your data? Yeah, so you know what happens when you get an alert. You go look at it. You have to treat every alert like it's a real incident. And I don't know. It varies by company, but I would guess that 50 to 70% of alerts are maybe not actionable or kind of false positives or borderline issues. So we've done a lot of work on how do we suppress that? And some of that is going back to the time series predictions, right? And thinking about if we can distill metrics out of some of the analysis we're doing, then we can do time series prediction on those metrics, and we can say, yeah, this is a little funny, but it's within the bounds of reason. We don't think it's worth waking someone up. And then finally, the fourth part where ML can really help you is explainability. So once you've decided there's a problem, what next, right? Oftentimes, you start crawling through the data in the table, you start trying to figure out like what are the healthy versus unhealthy records, where might that be coming from? You're going into your transforms, you're going into your lineage. And so we found that you can actually apply ML to do a lot of correlation analysis within a table or even across tables. And so you can find, if column A is corrupted, well, actually all the rows where column A is statistically funny, columns B and C are also weird, right? So, simple example, transaction dollars is 0 for a bunch of rows in this table. Well, that's correlated with a certain merchant or a certain payment rail or a certain point of sale system. And those kind of things, those like breadcrumbs and hints are what, if you can pull some of that stuff forward and see it, have the computer find those for you, it gets you so much farther down the path of assessment and analysis and correction. So we spend a lot of time thinking about that too. So that's the unsupervised machine learning part. Obviously, this is a journey. I don't want to just do a vendor pitch, but like it has taken us 5 years to perfect this magic, right? And it's a lot of science and a lot of work, but it pays off because it gets you out of that doom loop of just maintaining rules over and over again. But of course, there's still times when you want like row level accuracy, or you want to, define a custom metric that is really important for your business. And so, we've combined the unsupervised ML with fairly traditional validation rules, fairly traditional metric anomaly detection, as well as the, are the boxes moving through the warehouse kind of stuff that we call table observability. The difference in our validation rules and metric anomalies is that we've invested in making a whole bunch of no-code rules for those so that an analyst can come in and say, I want to monitor the median or the 95th percentile of this column, or I want to monitor that A plus B always equals C, and alert me directly if that's ever not true. And so that becomes like a really powerful self-serve mechanism. What's next? The logo didn't come through. There we go. So Block is one of our pretty early customers. We love them. They're fantastic. And this is their story, right? They have 500,000 production tables in Snowflake, Databricks, BigQuery. And it took them 2 or 3 days every time they onboarded a new data set to lay out the data quality rules for those. Their pages were on fire. They just had a huge never-ending backlog of tickets filed by their data consumers. And so after adopting this ML approach, they were actually able to count hours saved, right? Which is amazing. That's like 8 people years that they saved just not managing rules. So it's pretty powerful. Okay, so Amy talked about GenAI. We put GenAI in the title of the talk to get you here. GenAI is making the problem bigger, and the real problem is that none of the data quality approaches out there deal well with the unstructured data that you're being asked to process for GenAI applications, right? Customers I talk to, there's kind of 2 patterns for what they're doing with GenAI. One is pretty easy. It's like using LLMs to classify data that's been hard to classify in the past. So, like I was listening to a talk by someone at Roche yesterday who said, yeah, we're looking at, physician input comments to look for adverse reactions to our therapies, right? Because we have to report those. And so we have an LLM that can look at those comments and say, this comment does or does not mention an adverse reaction to the treatment. And so that's super powerful because it enables you to turn unstructured, kind of chaotic data into something that you can reason about and structure and use. The more complex case is we want to feed a whole bunch of documents into a GenAI app and have it give people advice or answers to questions. None of this stuff is going to work with those documents, right? Because the problems you have with those documents are not, are they 0 or null, or is it not an email address? The problems you have are things like, is there PII or proprietary data, or is this an old draft, or is this a gong call and someone got some abusive language in there, or is it factually incorrect, right? All of those are new problems, which is why we're working with some of our customers to work out like what are the patterns and what even are the rules for data quality for unstructured data. Super interesting. I'd love to chat with folks more about this if this is a problem you're working on. Okay. That was a lot. Thank you for listening to me babble. I wanted to show you briefly how we do this, like what our product looks like, how we've approached it. But one of the things we had to do was, to build this, we had to have predictably chaotic data, because you can't test a quality system without having data that trips all of its triggers and failures. So Netflix has this thing called Chaos Monkey. Maybe some of you have heard about this. Basically, it's a program that runs around in their production environment and like nukes VMs and turns off network circuits. Causes chaos because we all know systems fail, and so they wanted to get really good at building resilient systems that work around those failures. So I'm not sure why, but the llama is Anomalo's mascot. The employees are Anomalamas, which took me a while to learn to say. And so we built Chaos Llama, which in the spirit of Chaos Monkey corrupts data in tables, which sounds like your worst nightmare. So I'm going to use Chaos Llama to trigger some data quality problems and show you how we visualize those problems in Anomalo. And now we get to the live demo. Let's see how this works. Okay, so sneak peek. I know there's a few Anomalo users out there, but for those of you who haven't seen it, this is what Anomalo looks like. It's very high level. We're looking at a table called fact listing. And we run a bunch of different checks on this, right? We look for freshness and volume and anomalies and missing data. And then those key metrics and validation rules, which are more of the manually defined things that I talked about. And if I open these up, you can see, like, for this table, we've defined 3 validation rules and a key metric. And when Anomalo looked at this table this morning and said, hey, everything looks great, based on history, this is all perfect. There's a whole bunch of other like statistical breakdown of the table here, so we do a bunch of stuff. But let's see if my VM is still up and running. I'm going to launch Chaos Llama. So what this is it's a CLI tool, and it has all of these different ways of messing with the data in a table. Very dangerous. Do not ever connect this to production. So I'm going to do something simple. I'm going to mess with the values in a timestamp column. I'm going to do a time column value. So we talked about that fact listing table, right? And let's mess with the number of tickets. And the value, let's set the number of tickets purchased to 40. The timestamp column is list time. So what I'm doing here is I'm going to corrupt the num tickets column only for data from yesterday. So we're going to simulate, something went bad yesterday and the data that landed overnight in this table is wrong. So this is going to be 2024 10/08. So I'm going to manipulate yesterday's data. And I'm going to do like 30% of the table, or 30% of the rows from yesterday. Excuse me. And then here's the cool part. I only want to affect rows where the venue state is New York. So this is tickets sold in the state of New York, right? Okay, chaos caused. Super quick. So now in Anomalo, I'm just going to rerun the checks from yesterday. And so this is going to just go in, re-pull down the sample of data from yesterday, run our ML models over it. And you can see all this stuff now shows as pending. I'll just refresh this here. I'm not sure exactly how long this will take to run. But while it's working, what it's doing is first it's looking at, was data updated yesterday, right? Or we've learned the pattern of how often data in this table is updated, what those timestamps are. And so if we ever start to see, there's a lot less updated data from yesterday than previous days, that's a problem. right? If there's a lot less rows than previous days, that's a problem. If there's, we do a lot of those standard rules that you would write yourself are just baked into it, right? And it's part of it is ML, part of it is like, in the process of doing the ML, we have the ability to do this other stuff, so we just do it. Yeah, we're starting to get some results. Uh-oh. So we have some errors. And let me zoom in a little. What we're doing here is we're actually trying to explain what happened, right? So there's an unexpected change in the average number of tickets sold. Num tickets mean is not within the 95th percentile predicted interval. So something went wrong with our data yesterday. Let me just refresh one more time to see if everything is done. Still running our kind of complex ML, but you can see right here, this key metric failed, right? And this is a key metric that some business user has defined saying, I really want to know if the number of tickets sold is typical or atypical. So I'll click into this, and you can see so what you see here, the green is that time series prediction that I was talking about, right? And day by day, we're selling tickets, everything's great. Suddenly yesterday, the average number of tickets sold per transaction jumped way up, right? And this is obviously either maybe some venue like Taylor Swift did like a bulk ticket offer, or we have a data problem. And down here, I was talking about time series, and we actually do a bunch of explanation of which parts of our time series model are most predictive of this data, which it's a very data sciencey thing, but it kind of helps you understand, like, why is Anomalo saying this should be X, but it's Y? So it's pretty deep stuff. I won't get into that. But we've taken the approach of, like, surfacing all of those details because our users really care, right? Like they have opinions about ML models, about math, about statistics, and they want to know, like, why are you telling me that this is normal when I can see a variation? So final bit here. This is kind of my favorite, most magical check, the no anomalous records check, because it's really, this is the one that is saying, I looked at your entire table, statistically sampled, not every row, and there's something funny, right? So let's dig into what's funny, and there's a couple of funny things. The number of tickets is really anomalous, and it's actually going to show me, like, what are the top values in this table, and you can see suddenly yesterday there was this huge spike in the number 40. Like, no one buys 40 tickets, and all of a sudden, someone did. And then, well, okay, let's talk about root cause. Like, what else is going on in this table that correlates with that? And you can see it immediately plucked out. Well, the venue state is New York for 100% of those anomalous rows, right? So it's giving me those breadcrumbs. And this is all about the ML looking at the table, assessing correlations, and there's a whole bunch of non-ML in there too, right? Like, correlation analysis. But what we've done is we've surfaced, this is a problem in New York. It's pretty heavily correlated with shows, some plays, a few musicals. So that gives me the starting point to go and actually track down, okay, exactly what happened with our New York venue reporting. And that's how we approach it. We do a lot of work on alerting. I probably actually, if I go to Slack, yeah, I got an alert for this. As soon as Anomalo discovered that there was this anomaly, it actually sent me, a screenshot of that chart. So I can even, from here, take action, right? Okay, that's enough demo for now. Yeah, so, some thoughts about how we fit in with DBT, especially with the new control plane and everything they're talking about this week. One thing is you can monitor the semantic layer key metrics with a time series ML prediction system, right? And that is going to help you keep track of your business metrics and help you stay on top of knowing that dashboards are going to be funny today and being able to proactively communicate out to those stakeholders before they come asking questions, right? And that loops all the way back to building trust. you can probably delete a lot of DBT tests, data tests, unit tests, if once you have this system up and running, you start to get confidence in what kind of problems it catches. And then you can just go through and start deleting tests that are duplicative, right? And that saves a lot of time, can save some cost. And this is all built for scale, right? It's really not a problem when you only have a few tables or a few pipelines or a few models, but when you've got 10,000 or 100,000 tables that you care about, it's all about the scale. And then I had some thoughts on things to pay attention to as you're embarking on GenAI projects around data quality. So I'll leave these as an exercise for you all. You can take a picture of it if you want. And that's it. Thank you. And Amy and I are here for the duration, so
Yeah.
come chat.